Hello everyone. So welcome back to the Let's Unbond past paper discussion. Today we are going to discuss in the same series 11th question, and it is a quite bigger one. So let's solve it step by step. Okay, so it's a total of 16 marks. First thing is very simple. There is a 3-digit code given ABC. ABC is one among these numbers 1, 2, 3, 4, or 5. So now we need to find total number of possible codes with repetition. So one, like same 1, 1, 1 can be used, 2, double 2, 3, something. It can be repeated. And the second case is without repetition. So let's take it's a current kind of arrangement. So A, B, C. With repetition, the number of ways to fill the slot for A is 5 ways. And this also 5 ways. This also 5. It's a counting technique by multiplicity. So 5 times 5 times 5, it's going to be 125. That's simple. In few seconds, we can solve this. 125 possible codes when it is with repetition. And without repetition, same we need to fill, but we have to take care that it's not repeated. So if 1 I have used here, then apart from 1, the other 4 will be applied. Okay. So the number of chances to fill the first is 5, and second is 4, and third is 3. So one option will get reduced, and you multiply all these stuff. 5 times 4 is 20, 20 times 3 is 60. So no repetition, we have very less number of codes. So 60 possible here. Okay, just a 1 minute, and this will fetch us 4 marks. Next. P of x is, it's a polynomial. It's a cubic polynomial, x cube plus ax square plus bx plus c, where a, b, c are the same that we deal with, right? One of the values of 1, 2, 3, 4, or 5, and here no value repeated, which means 60 possibility is there. And P of x has a factor of x cubed plus 3x plus 2. This is the case we have now. And we have to find an expression of B in terms of A. Okay. A P of x has a factor of x cubed plus x plus 2, right? So I can factorize this, and let's apply the remainder theorem, factor theorem, right? So I'm going to consider this. P of x has a factor of x square plus 3x plus 2. So let's factorize it, splitting the middle term. This will go like x square plus, we can split it as 2x plus x plus 2. Take x common, it will be x plus 2 here, and take 1 common, it will be x plus 2 again here. So x plus 2 into x plus 1. So P of x has a factor of this, means I know the factor of this. So since x plus 1 is a factor of P of x by the factor theorem, so P of minus 1 will be equal 0, and we can solve for it. P of minus 1 is 0. Let's substitute what is P of x. I'm writing it here for the reference. P of x is x cubed plus ax squared plus bx plus c. So P of minus 1, when I substitute, minus 1 the whole cube plus a minus 1 squared plus b times minus 1 plus c equals 0. And it's minus 1 plus a minus b plus c equals 0. So we got this. Let me simplify. All variables on one side, number on the other. Okay, we will use this. Let it be named as equation number 1. And next, P of x has a factor of this, right? So x plus 2 is also a factor. Then if x plus 2 is a factor, P of x means P of minus 2 equals 0, right? By factor theorem. So the reference for P of x is this, x cubed plus ax squared plus bx plus c. And let's start substituting. Minus 2 the whole cubed plus a times minus 2 the whole squared plus b times minus 2 plus c equals 0. Let's simplify this further, which is minus 8 plus 4a minus 2b plus c equals 0. So 4a minus 2b plus c equals 8. This is my second equation. Okay, we have 3 unknowns here. And actually, what is our aim? In this case, we have to express b in terms of a. Okay, b in terms of a. Let's take the first equation. So 1 is, from the 1, let me rewrite c equals, because c is the thing which we don't want, right? So I'm going to take the first equation and rewrite this as c is equal to 1 minus a plus b. Okay, let it be a, and I'm going to use it. And the second also, I can write c is equal to something. C is equal to 8 minus 4a plus 2b. And I'm going to use these two equations now. This one. Over here. And this one too. Okay, so naming is not needed. Let's just skip this. And okay, using this, both are representing C, so I can just equate them. I will get 1 minus a plus b equals 8 minus 4a plus 2b. Now, what is our aim? B in terms of a. B equal to kind of something of a, right? And let's start simplifying. A on one side. Okay, B on one side. Let me focus. I'm just changing the B over here. It's 2b minus b. And here 1 minus a minus 8 plus 4a. So 2b minus b is b. 1 minus 8 is minus 7. 4a minus a is plus 3a. So to give it a best answer, b is equal to 3a minus 7. B in terms of a. That's simple. So next part, prove that there is one and only way to assign the values, and that is for A, B, C, that is this 4, 5, 2 combination. Okay, but actually we have 60 possible outcomes. But the one and only way here, just like A, B, C simultaneously, it should get satisfied, and this is the only way we need to prove. Okay, so first A, B, C can take one among this 1, 2, 3, 4, or 5. First of all, I have a relation between A and B. We can use that. So B is equal to 3A minus 7. Also, I have a relation for C, two relations. So I'm going to take the simpler one here, 1 minus A plus B. And so when A is equal to 1, we're going to try find the trial and error. When A is 1, what will happen to my B? My B is 3 times 1 minus 7, and B is going to be 3 minus 7, which is a negative, minus 4. It's not possible. And I won't try C. So A1 is not possible. Then let's go for A2. When A is equal to 2, B is going to be 3 times 2 minus 7, which is 6 minus 7. which is 1. Okay, 2, 1. Maybe let's check for C now. Because B is possible here. And C is 1 minus A plus. So 1 minus A is 2. B is 1, which is 0. This is not possible. We don't have this 0 available over here. So we won't, this A is equal to 2 combination is also not possible. Then when A is 3, B is equal to 3 times A is also 3 minus 7. 9 minus 7 is 2. Okay, it seems like it will work. But let's check for C. C is 1 minus A is 3 plus B is 2. It's again 0. So not possible. And then when A is equal to 4. Okay, 4 and 5 we need to check. Let's check for 4. When A is equal to 4, B is 3A minus 7, and C is going to be 1 minus A plus B, right? So let's solve. B is equal to 3 times 4 minus 7, which is 12 minus 7, which is 5. Okay, it holds. And C, 1 minus 4 plus 5. 6 minus 3 plus 5, it's going to be 2. So this combination is what possible. This is what I need to prove. A is 4 and B is 5 and C is 2. Okay, so this is possible, but this is the only way to possible. Means I proved the all other like 1, 2, 3, that combination will not work. Let's try for A is equal to 5. So if I prove this is also not possible, then it automatically states hold, right? So when A is equal to 5, B is equal to 3 times 5 minus 7, 15 minus 7, which is 8. This is not at all in our number list. So no need to try the next part. And this is the only possible combination. So hence A is equal to 4, B is equals 5, C equal to 2 is only possible combination. And hence it's that's it. So second part. So P of X we need to express as a product of linear factors, the third part, right? So let's take P of X is equal to it's X cubed plus, I know the only possible A values, right? 4x square. This is what our P of X for your reference. I'm writing it here. X cubed plus AX square plus BX plus C. And what are the only possible A values? 4, 5, and 2. So x cubed plus 4x square plus 5x plus 2. I know, and they have mentioned like x plus 2 and x plus 1 is a factor, right? So x square, we know that. X square plus 3x plus 2 is a factor. And you can express this as x plus 2 into x plus 1. This we have already covered, just we are reiterating it. Okay, so to find the other factor, we have to divide this. Dividing will work. So let me divide to find third factor. I'm going to divide P of X and divided by x square plus 3x plus 2. The quotient will be, since it is a factor, you will get 0 as a reminder. So P of X is x cubed plus 4x square plus 5x plus 2. Let's start dividing this. Okay, so x square plus 3x plus 2. And so first term divided by the first term, x cubed divided by x square is x. So put the x over here and you will get x cubed. Now multiply this plus 3x square plus 2x, right? Divided by and change the sign for all of the new parts. And this for sure will get cancelled and this will become x square plus 3x plus 2. And exactly the divisor and this are same. So you just put a 1. And you will get x square plus 3x plus 2. Of course, here we should get the denominator, the remainder 0. Because this is a factor. All of them get cancelled. And the third factor is this. So, P of x is equal to the x plus 1 is a factor into x square plus 3x plus 2. This we already factorized it. So x plus 1 times x plus 1 into x plus 2. This is a product of linear factor. And you can also mention like this x plus 1 whole square into x plus 2. So P of x as a product of linear factors is 10. And the last part, hence or otherwise sketch y is equal to P of x. So we can use all the attributes and key factors which we have solved before. And we need to sketch it. Particularly, we have to clearly show the x-intercept, coordinates of the x-intercept. So let's start solving. Okay, first we need to, since it's a polynomial sketch, test the end behavior and let me write the polynomial first. In factored form will be best. P of x is equal to x plus 2 into x plus 1 the whole square. End behavior of the graph. Okay, how will you test the end behavior? So degree we need to check. Degree is odd, it's a cubic. So you have to maintain a cubic structure for the graph. And leading coefficient is positive for sure. Is positive. So the end behavior will be to the left, it's down. To the right, it's up. Okay, it will be reaching infinity. Then after, okay, we know the cubic structure, something like this. And then we have to test the x-intercept and y-intercept. So x-intercept is a kind of zeros. Also, this is the important aspect in the question they have mentioned as a coordinates. So x-intercept is first factor. I'm just taking this equal 0. This is very important. It's a squared factor, right? So the x-axis will act as tangent when you have a power 2. X-axis act as tangent at this point. So what is that point? X plus 1 equals 0, x is equal to minus 1, and y is equal to 0. So minus 1 comma 0. And one more intercept is x plus 2 equals 0. This is just a normal thing. So it will just cross x-axis. Not like a tangent stuff. Okay, next one is y-intercept. So these are end behavior and then x-intercept. Now coming to the y-intercept. So it's very simple. Set x is equal to 0. So y is equal to, like this is my y, p of x, right? X plus 1 whole square times x plus 2. So when you substitute 0 plus 1 square into 0 plus 2, it's going to be 1 times 2, which is 2. So 0 comma 2 is y-intercept. Right? So these are the things. Then we can directly get into the graphing part. Let me draw the axis. Okay, we mostly have the zeros as -1, 0. So plot -1 and -2. In -1, it's like a tangent. Okay. And then y-intercept is +2. +1, this is +2. I know the cubic structure, it's going to be something like this. Leftwards, it will be dropping down. Rightwards, it will be moving up. So the graph should cross this y is that is -2, right? So the graph will increase and it will cross. Wait. A smooth curve. And then it should go down. It will act as a tangent stuff. And I need this particular structure. So let me go like this. At -1, it's a tangent because we have the exponent factor is 2. So there will be no crossing here, just it will touch and move ahead. But it should touch 2. So let's go like this. You make a tangent like this. Here across, here across. Okay. And we can model in this way. Okay. So this is the required graph. And that's it. And we have shown all the structures over here. And end behavior is also perfect. So this complete the solution. And from this is a 14-mark question. Yeah. 12, yeah, 16-mark question. So this second part consists of like almost every polynomial basics. So that's it. Thank you so much for listening.